Hi, welcome to our presentation for the Smell Vancouver project, where we focused on establishing a link between industrial emissions and citizen odor reports. So my name is Divya, and these are my teammates, Julia and Jake. And first and foremost, we want to extend a thank you to both our DSSG team, our Smell Van team, and our project sponsors for all the support that they provided us during the duration of this project. So just to give you a brief summary of our agenda today, first we're going to introduce to you all of the background information that you need. So we'll be defining any uncertain terms and concepts for you, and then we'll be touching on our objectives of the project. Then we'll introduce to you the data that we used and how we manipulate it to get our results and our findings. And then we will discuss our conclusions and limitations and ways we can improve our results for the future. Then we will discuss our impact of our project on the community, and then we'll have a question and answer period for any questions you may have. So to get started on the background info, one of the most important questions that we want to ask is, why did we choose Metro Vancouver? So Metro Vancouver is a large area that does not only refer to Vancouver downtown. It is a collection of cities, districts, municipalities, villages, and one Treaty First Nation with a total population of about 3 million. It accounts for 50% of British Columbia's population and so has the highest population density in all of BC. Unlike other cities where odor reports have happened, like Pittsburgh that has a large sulfur problem, Metro Vancouver does not have one single concentrated odor source. About half of Metro Vancouver's land use is made up of conservation and recreation, followed by general urban areas and agriculture. And this is because Metro Vancouver is mostly an economic area and not an industrial city. That being said, smells occur in pockets around the region, and industrial waste and processing facilities constitute a majority of the potential sources based on the smell profiles. In addition to that, as you can see, the slide in these different regions are made up of distinct areas with distinct facilities. This makes connecting odor sources to odors much more difficult and tricky.
So to make the odor source connection, we sort of start with this conceptual approach where we have an emission that is a chemical that's generated from an emission source. There's lots of different emission sources. They can be biogenic in nature or they can be anthropogenic in nature, biogenic being related to natural processes and anthropogenic being related to human activity. Once an emission is dispersed into the environment from a source, it becomes a pollutant. And those pollutants are influenced by meteorological factors, such as wind, and eventually they may reach an individual. Not all of these pollutants are detected by individuals, but some are, and they're detected as smells. And of these, some are recorded in the smell van dataset. So the way that we get that data is that it's constructed using this citizen science app called the Smell Vancouver app. This app was constructed as a community science product for determining the burden of smells on citizens in Metro Vancouver. So users can report the location of where the smell was observed, some information about that smell, as well as some demographic information about themselves. So far, the Smell Van team has linked this data with air quality and meteorological data with the overall goal of understanding the links between urban odor, air pollution, air quality, and health effects. This is a pretty unique data set, and what makes it unique is that it takes a very human-centered approach to measuring the impact of odors. There's a couple different sort of smell projects in cities in North America, but they take a very chemical-focused approach to odor measurement. In contrast, the Smell Van app focuses on the impact to the individual, as well as the perception of odors. So it uses a model called the STOSAC model, which stands for the spatial, temporal, odors, symptoms, actions, and causes associated with an odor, which provides a much more human-based data set that includes the perception and impact of those odors. So this data is a great measure of the impact of smells. However, it's important to understand that this reporting is a complex phenomenon subject to environmental influence and the same limitations present in all of this community-based type of data acquisition.
So community science is a process where scientists will turn to the community for data collection. Since one of the most effective ways to detect odors is the nose, the Smell Van team decided to use community science. And there are many advantages to this. For example, the data collection will usually exceed the capabilities of any one research team. So there'll be more data participation, and scientists will have access to perspectives and information that the community has that they might not otherwise have access to. But there are also advantages outside the research problem, such as building stronger connections between the public and research teams. However, there are some disadvantages to community science. Since the data collection is dependent on voluntary reports, large amounts of data can take a long time to accumulate, and that time is also dependent on how much scientists are able to quote-unquote advertise their studies. Another concern that scientists may have when using community science is the quality of that data. Since the data is being provided by a large variety of people, the data they receive may not have the granularity that they want, or it may be heavily biased towards certain things. Additionally, there is no guarantee that every report is being done seriously. That being said, there have been a couple studies, and I've linked them there, that prove that the majority of reports from community science are trustworthy. And it is these advantages that the Small Vancouver team decided to create an app that citizens can log odor events that they detect. So just to give you a quick refresher on everything that we've accomplished so far, we have a timeline here. So at the beginning of the project, in May when we first started, we created a land use inventory from Canada's AAFC crop inventory for Metro Vancouver that basically outlines how land is used within Metro Vancouver. And then we created a temporal disaggregation of estimated industrial emissions for an emissions inventory. Using those two data sets and the data from the SmellVan app, we did some exploratory data analysis, which we presented in the midterm presentation. After the midterm presentation, we wanted to explore the relationship and do the analysis of temporal relationships between the reporting and estimated emissions. But that didn't really work out well for us, so we had to pivot our project, and instead we decided to do spatial analysis of known industrial emissions and odor reporting. And using that analysis, we were able to build a product for citizen scientists in the form of a web application.
So since we had decided to focus on that community science aspect of the project, we tried to come up with some aligning objectives that would kind of be in service of that perspective and help answer some of the questions that individuals affected by odor may have about those odors. In particular, we wanted to answer these questions. So we wanted to know, are some reported odor types more proximal to certain kinds of emissions facilities that we have data on for Metro Vancouver? We also wanted to know if there are unique spatial clusters of reporting in Metro Vancouver, and within those clusters, how does the reported odor vary? And then we were also interested in examining how reported odors travel over time. So we used a couple different methods to try to get this result. You can see here on the map, these are all the odor reports, and the color signifies a different odor. So parsing these out took a couple different approaches that we'll explain throughout the presentation.
So while working on this project, we focused on mainly two data sets provided by our project sponsor, in addition to some open source data sets. The first data set comes from citizen reports. This data set has approximately 550 unique reports. It has the geospatial data of where the smell was reported, the date it was recorded, strength of the odor, and other descriptive features like any symptoms the reporter may have experienced, any actions taken after the reporter detected the odor, and its possible causes. The second data set is an emissions data set that is organized by industry type. We had several sheets of data, one sheet for each industry type, and there were a total of 12 industries which we merged together. This dataset originally had 36 rows, which we temporally disaggregated into 365 rows. It includes the average amount of emissions that an industry produces on a specific day. And lastly, this dataset is an open source dataset obtained from Metro Vancouver's data portal. This dataset contains the spatial data for public and private garbage and waste facilities, as well as the cannabis cultivation facilities. So like I mentioned in the last slide, there's about 12 industries in our emissions inventory, but due to the data unavailability and inaccessibility issues, we focused on these two industry types since this data was readily available. Moving on to methods. So our analysis mainly focuses on two approaches, proximity analysis and cluster analysis. So we'll go over the proximity analysis first. So to answer the question, does the nature of reported odors change based on proximity to different emission source types? We looked at how reported smells vary as a function of proximity to known sources, and we defined an odor risk zone as the area around each source type that produced the largest difference in reported smells between reports within and outside that risk zone. For example, if reports within 100 meters of a particular source type complained of a very similar odor to the reports outside this radius from a similar source type, then we can hypothesize that proximity was not a key factor in reported odor at this distance. So we would increase the distance until the maximum difference in reported odors was observed. The rationale for this question from a community perspective is that if reported odors vary significantly within a certain proximity to known odor sources, then this may represent an odor risk area for that particular source. So now the proximity analysis allowed us to establish a potential connection between specific sources and reported odors. We need to identify more regional patterns in the reported odors. So we decided to supplement the proximity analysis with a cluster analysis approach. Since we know that different regions of Metro Vancouver have different profiles of industrial activity, we were interested in determining if there were spatial clusters of odor reporting, and if the reported smells in those clusters had any qualitative relationship to the industries in those areas. So we applied several different clustering algorithms to see if there would be any overlap in the clusters that were made. This would give us a sense of what appropriate clusters would look like, and if we can be confident in our clustering results.
So as we mentioned previously, we wanted to create an app that allowed the community to see what was happening with their information. As data scientists, it's important that we do not only process data and make conclusions from that data, but also be able to communicate those results to people that may not have the same technical background or industry knowledge. This ability to communicate is so important because it makes information more accessible to people of all backgrounds, thus allowing them to bring more ideas to the table that we might not have had ourselves. This also strengthens the bond between scientists and the community and creates a deeper level of trust. So when you first open the app, So when you first open the app, the first thing you'll see is a heat map of all the facilities on cannabis and garbage facilities that we have. You can toggle that on and off on the left, depending on what you want to see. You can also select what reports you want to see. Here we selected odor reports of all odor types, and they appear as clusters on the map. When you zoom in, they'll disperse and you can see exactly where in the cluster they are. And if you click on them, you'll see which odor type it is. You can do the same thing for possible cause, and you can filter the reports by date. And this sort of tab just serves as sort of an introduction to our web app, and it's there to give the users a brief understanding of what the report data looks like.
All right. So that's there's a couple tabs in the app. That's the first tab. It's more of a descriptive tab. The second tab is the proximity analysis tab. So for the proximity analysis, we focused on waste facilities as we felt that was the best data for industrial sources that we had. As mentioned in the methods, the underlying approach was based on determining what is the distance at which reported odors change the most based on whether or not they're within that distance or outside of that distance to a certain source type. We felt that individuals that were living in that risk area could perhaps use this information to understand the risk and odor profile of an area of interest and possibly use this information in advocacy efforts down the line to address high-risk odor sources. Okay, great. Here we are. The first step in kind of determining the spatial cause of reported odors is establishing that proximity to sources is actually important and influential for the distribution of where odor reports are. Since an odor is a gas, we could hypothesize two likely scenarios for how odor spreads through space and compare what these hypotheses would predict with the observed patterns in the data. So under scenario one, as demonstrated here, we could assume that odor is a function of proximity to sources and that odor spreads by diffusion. This would predict that we would observe like a large amount of reports close to sources with a reduced amount of reports as distances to sources increase. You could visualize this predictive pattern as kind of a cone of probability that sits on top of each source with a high likelihood of observing a report as you're close to that source, and decreasing probability of observing a report as that radius increases. So if we observe that in the data, that would imply that that distribution of reports is a process mostly driven by diffusion, and that proximity is important. On the other hand, taking the other extreme, it's possible that odors are primarily spread by wind and that their distribution is dictated by patterns of convection in the atmosphere. So assuming maximum wind over time, the reports would aggregate in an area far away from sources, determined mostly by the strength and direction of that wind. In this case, these odors wouldn't have enough time to linger in the area around where they were caused, as they would be quickly transported far away from that source based on the dominant wind in that area. So we can test these hypotheses in the data by examining the prevalence of reported odors as a function of distance to sources. So what you're seeing here is for all the reports and all the sources, what's the probability of observing a report based on how far you are away from that source. At higher distances, you can see that the likelihood of observing a report falls fairly quickly in a nonlinear way, which visually kind of lends more support to the hypothesis one, that the spatial distribution of reports is likely a function of proximity, and that most of the spread of reports is a function of diffusion rather than wind. This lends some initial support to the hypothesis that proximity is important. We can continue to break this down further by examining how that kind of proximity likelihood changes based on different reported odors and causes. So on the left, you can see that same plot for all reports that identify themselves as being caused by garbage and waste, and the likelihood of observing those reports based on distance to cannabis cultivation and garbage and waste facilities. So you can see there's some differences there. And there's more confidence in the garbage and waste facilities. On the other graph, you can see for all reports that are reporting an odor of rotten smell, they are much more likely to be observed close to garbage and waste facilities. So we can look at this on the map using the proximity analysis tab. So here you can see the odor reports in black and the garbage facilities in red. The garbage facilities are plotted as points on the map, but they also have radii around them, which is indicating whether or not the reports are proximal or not. We plotted this at 2,000 meters because this was the distance that provided the biggest difference in the types of reports that were close and the ones that weren't. And we use circles based on the assumption that wind is not particularly influential in how reports are distributed. So we can examine the differences in reported odors that are either within those circles or outside of those circles. So in that 2,000 meter range to garbage and waste facilities, that contained 36% of the reports in the data. Comparing the distributions for reported odor outside that proximity and within that proximity, you can see that reports closer to waste facilities are more likely to be of type rotten. So that's 54% of them versus 44% of them. And reports of type chemical are observed with 30% less frequency for the reports that are close to garbage and waste facilities versus the reports that are not close. So this illustrates that reports closer to garbage and waste facilities do differ in their reported odor, and that odor profile is kind of consistent with what we might expect to see given that source type of garbage and waste. We can investigate the same effect by looking at reported cause for odor reports, and we can see that again it does differ based on whether or not you're close or far away from garbage and waste facilities. So proximal reports are reported as caused by garbage and waste with about 30% more frequency, indicating that these reports differ as a function of proximity and that the size of that risk zone around garbage and waste facilities might be somewhere around 2,000 meters in radius. That size of the risk zone may also be related to the chemical composition of the typical pollutants associated with garbage and waste facilities. It has a lot to do with travel.
So moving on to our next analysis method, which is clustering. And we hypothesized that if certain clusters have different smell profiles, and the industries around those areas are different, then this may be representative of chronic smells produced by those industries. So first I'll walk you through the purpose of this tab and how to use it. And we wanted to include a clustering tab because we wanted to explore if there was a spatial relationship between groups of clusters and facilities, and also if there's any relationship between clusters within each group. So on the left, you can choose a clustering algorithm here, and then you can filter by cluster of interest and select a date range, and you can also toggle on and off the industry type to display the industries that you want on the map. The clustering algorithm that you can see on this map here is dbScan. The specialty of dbScan is its ability to find high-density regions and separate them from low-density regions, and it's not powerfully influenced by noise or outliers. From this map here, you can see that it groups 3 clusters together. So we have the orange, the green, and the purple one down at the bottom. The gray points that we see around here are not actually clusters, and they're what dbScan considers to be noise. Essentially, dbScan here has allowed us to identify clusters, which we believe are a good metric for chronic odor exposure, and this is something that Metro Vancouver is very interested in. And we decided to use dbScan because of its ability to capture non-spherical clusters. So for example, like Jake was mentioning, if smells are indeed influenced by wind, then the quote-unquote true shape of their cluster may not have a circular shape that other clustering algorithms like K-means are looking for. So in this slide, we're showing you the clusters that were made by the K-means algorithm, and we decided on 6 clusters by using our elbow plot. And one thing I want to point out about the K-means algorithm is that it's clustering together points from Bowen Island and West Point Grey, but intuitively, this does not make sense. So this is the elbow plot that we used to determine how many clusters we wanted for K-means, and we want to look at where the bend in the plot occurs. So ideally, you want to find the smallest amount of clusters that has the lowest sum of squares value. So here we could choose somewhere realistically between 4 to 7 clusters. And we plotted them here for your visualization. And we ultimately decided on 6 clusters because we thought that 4 and 5 were grouping too many reports together and we were losing some granularity in the reports. And then we thought that 7 was creating separations where there shouldn't be. So 6 best captured our regions of interest.
So one interesting case that we want to show you occurs in the cluster around the Delta region. So according to CBC, for several months in the year 2020 and 21, residents have been reporting incidents of garbage smells around the region. And this has been an ongoing issue in Delta for several years. One local resident says, quote unquote, "It's gross, it feels like you're living in garbage." Another local resident's complaint says, quote unquote, "It smells as if you let garbage out in the sun for a few days." So this resident's home sits around 1 kilometer away from the industrial composting plant, and this is the area that's being highlighted in our cluster here. In addition to the map that I showed, you also have these 2 graphs. So these graphs show the distribution of reported odors and causes in that cluster that you have chosen. So in this example, for the cluster around Delta, we can see that a large majority of reports were reported as rotten, and the cause was garbage and compost. So this is interesting because of the prevalence of garbage dumps in the region, and this shows that there is some merit in using spatial clustering. So the last set of clustering algorithms that we used are types of hierarchical clustering algorithms. We found the optimal k-value using both the elbow plot and the silhouette plot. So first is agglomerative clustering, which is a bottom-up approach. And what it's doing is it's making decisions by considering the local patterns without initially looking into looking into the global distribution of data. Whereas divisive clustering is a top-down approach, and it's taking into consideration the global distribution when making those top-level partitioning decisions. So out of these 2, divisive algorithm is the more accurate but computationally expensive one. And an important thing worth mentioning is that hierarchical clustering is actually an improvement to our K-means algorithm because we have much clearer and distinct clusters. An example is the Bowen Island cluster that Divya mentioned. So here, it's being captured by the hierarchical clustering, which wasn't being captured in the K-means. So as mentioned, divisive clustering is a top-down approach, and this is clearly reflected in the way that the top 2 clusters differ from the agglomerative clusters. And as we've seen so far, the clusters from K-means and hierarchical clustering were slightly different in how they were generated, but you still have those distinct regions being captured by these clusters. So we can say for the purpose of our study that these clusters are more or less the same, meaning we can assume that these clusters have approximately similar within cluster variation, indicating a good compactness, or in other words, clustering.
So now to sum up our results. We know community source data suffers from underreporting and has traditionally been extractive in nature. So our goal was to create a product that would allow users to explore their own data and address their own questions. We anticipate that these users would broadly fall in one of two categories. One, users that want to find the source of smells, and two, users that are interested in how smells differ per region. Our product will allow both types of users to explore their data, increasing community engagement with the outputs of scientific data, acquisition analysis, as well as increasing the likelihood of those individuals will continue to engage community-based science in the future. We also want to present some limitations, and some of these are similar to the ones that we touched upon in our midterm presentation. And so since we're working with crowdsourced data, the presence of reporting and socioeconomic bias is apparent. Additionally, we have identified potential confounders like weather measurements and emission estimates, which we would like to explore in the future. And lastly, there is a good possibility that there are some unmeasured causes of odors from other industrial and non-industrial sources. So future research will involve making sure that we have a much more representative sample to capture those unidentified odor causes.
So as Data Science for Social Good Fellows, it's in our interest to explore the impact of our work on the society. So here are some of the social impacts from our project. We can safely say that this project will encourage the practice of public participation and collaboration in scientific research to increase the scientific knowledge in the community. And with a larger database of odor reports in the coming years, our work can ensure a data-driven decision-making process when it comes to policy interventions and its impact measurement. So for example, Metro Vancouver plans on amending their cannabis regulations, and our analysis here can directly contribute in that decision-making process because we can provide them the statistical evidence they need. Yet another way our work directly aligns with Metro Vancouver's interest on this issue is the emissions inventory that our team developed early on in the project, which can be built into the chemical transport models that would map out the evolution of air pollution in Metro Vancouver. So this inventory is very important because we need the emissions mapped onto a spatial temporal space to perform any kind of air pollution modeling. So one of the integral part of our project was making our analysis accessible to the community. So we focused on a more visualization-based analysis rather than a mathematical or statistical one. So for our future goals, with a larger sample size, we would like to explore the modeling approach to find likely sources of odors. We have built a foundation for this analysis, which we can discuss in Q&A. During our analysis, we also came across a spatial temporal clustering algorithm in which the time dimension was introduced into the spatial data. And to go with this, we had worked on spatial temporal visualization as well that tracks the movement changes of odors. So this is a work in progress. So we have attached the animation that we generated in the appendix by reference. Moving on to other future goals, we want to include additional layers to our maps, layers like estimated emissions and land use types, and also the remaining 10 industry types. So these additions would broaden the scope of our current analysis. And then an important one is we would like to deploy and scale our web app to handle more users and the evolving needs of the stakeholders. Lastly, we would like to use our analysis to determine the risk area for cannabis cultivation to facilitate in the policy interventions. And I'll hand it over to Jake to talk a bit more about that.
Yeah, so we felt like the cannabis question was an important one to spend a bit more time on because it is a stated interest of Metro Vancouver to regulate cannabis cultivation facilities. Metro Vancouver is currently engaged in defining what the risk area may be for cannabis cultivation. There's a proposed minimum distance requirement that outlines that new cannabis cultivation facilities must be located at least 200 meters away from land zone for residential use, hospitals, schools, daycares, playgrounds, and community care facilities. So we can actually contribute some analysis to this question using the same approach that we took for garbage and waste facilities. So if we look at our app in the proximity analysis tab, we can select cannabis cultivation facilities and display them on the map as red circles with those radii that are defined based on the approach we discussed earlier. The black points are the reports. And when we do that, we can investigate in the same way what is the breakdown of what's the difference in reported odor based on whether or not reports are close to those facilities or not. But what we see is kind of a lack of an effect. So we selected to display to you today the radius that produced the biggest difference in reported odors, but not much of a difference was observed across all distances. And when we look at the results from this, we see that reports that were closer to cannabis facilities were a bit more likely to report rotten smells, 52% versus 48%, and a bit more likely to report smells as fishy, which was about 8% versus 4%. So there's a bit of a lack of a cannabis signature in the data. We can look a bit deeper at what the reported cause was in the data, because we do have a category that is a reported cause of cannabis. But when we do that, instead of seeing kind of a canary in the coal mine for cannabis, which would be a spike of the cannabis category in this within proximity graph, instead we see no increase, but an increase in reports of type NA, about a 35% increase. And that's for reports that are within 1,200 meters of cannabis facilities. So what this might indicate is either that users are not being directly affected by cannabis emissions as much as we previously thought, or perhaps the app is not optimized to collect this type of data from users and might need to be amended. But it could have important policy implications down the line for both the app and the regulations. I'll just point you towards some supplementary analyses that we did perform but didn't put in the presentation. If you're interested, we can talk more in the Q&A. We looked a bit into identifying the spatial temporal progression of reports of similar causes for fixed intervals. We set that at 3 days because we figured that might be the length of an odor event. We did some work to understand which reports are anomalous versus chronic. And then we also did some work where we took those emissions estimates and mapped them spatially to their sources based on industry footprint. So we can use those emission estimates to try to get a sense of what's happening spatial temporally with those estimated emissions. Finally, I encourage you guys to check out both the Smell Vancouver app, which is the QR code on the left, as well as our analysis app, which we named the STINKO-SAC, which stands for Spatial Temporal Investigation into Known Odors, Symptoms, Actions, and Causes. Hopefully it's still working. It was working when we started the presentation. So, yeah, with that, we'll be open for some Q&A. Thanks for your time.
Yeah, thank you for your presentation. So I'll open up the floor to anybody who has questions for the team, and also those of you joining us virtually, please let us know and let me know by raising your hand or typing your questions in the chat. We'll get to those as well.
Yeah. I have two questions. So I think you did like this proximity analysis that you talked about where you looked at whether the distribution of reports in relation to like sources or distance from sources. And you were talking about the two hypotheses of like spreading by diffusion compared to by wind. And do you think it would be useful to look at like not just the distribution of like how far away these reports are from the sources, but also the shape of the distribution, like geographically, like is it circular or does it look like a big line, that sort of thing? Is that something that would be useful to look at?
Yeah, I think I sort of took on the proximity analysis, so I can try and answer. I think one thing that we had to define proximity based on like some input that we gave, right? I think what you're sort of suggesting would be that if we could if we knew with a little bit better certainty about where the reports were coming from in terms of their source type, then we'd be able to kind of change like what the shape looks like. But for now, we kind of we approached it kind of the other way, right? Where we had to say, it's a circle and this is the radius of the circle, and then just look qualitatively at how the reports vary. That could be something that we could maybe think about using DB scan for, because it can produce like more ellipsoidal clusters. But yeah, like incorporating wind, we just didn't really figure out a way to do it at the time we had.
Yeah.
Yeah, I think the wind measurements that we had were aggregated, so the data was inaccessible, and we did have an option for the open data source, but it didn't really fit with the data that we had. And also for adding on to the DB scan idea, we did try to perform clustering with odors as well, and not just latitude and longitude, but we couldn't find a way to get like distinct clusters, at least not visually. Those didn't make sense. And when we looked at those, the profiles of like where the odor was, so what kind of odor was reported and the possible causes, those were a little out of sync. So I think we still have some work to do in the future on that, but that's something that we can include in DB scan as well, is modeling the odor into it.
Okay.
There is a question from the screen. So Leon, if you could turn on your, yeah, that's good.
Hi, can you hear me?
Yeah.
Hi, yeah, great presentation, thanks. I just wanted to ask a question about the proximity part of your talk. I think it was towards the end where you presented this sort of classifications for the various proximities to certain possible sources of smell. So, one of them, for example, was this was an investigation into the possible repercussions of cannabis production facilities. So I guess my question was there any consideration of, because on the y-axis on those plots, it was, if I remember correctly, just sort of like the total number of reported cases. Yeah, this one here. Yeah, total number of reports. So I guess, am I right in saying that this would assume that it's that it's the same general population density surrounding each of these possible sources? Because otherwise, I guess maybe you would want to consider the let's say like the number of reports per capita in a certain region. So yeah, I was just wondering if you had kind of thought about that at all.
Yeah, we had thought about that, absolutely, and we were interested in trying to come up with ways to adjust for population quantitatively and visually, and we do have that data. We just we kind of ran out of time to incorporate it into the analysis. But looking at an adjusted analysis of kind of population-based propensity to report, and then how that influences the observed report, would be like a really good next step for this work, I think. Yeah.
Great,
Hopefully
thanks.
that answers the question.
Yeah, absolutely. Cheers.
Amelia, would you like to comment?
Yeah, I'm just curious because like it seems like outdoor can change with time, especially as you mentioned, right? The wind will be probably the good indicator, right? Where the certain areas will experience some outdoor. So I just wondered, did you have a chance to look at any temporal trends?
I think, so are you asking temporal trends of these movement tracks of odors as a function of wind?
Not just even like looking at the map, right? You probably plotted all the occurrences where the smell occurs. So I just wonder, is it like consistently the certain places experience the outdoor, or it's maybe only like 1 hour, in a year where the place was experiencing some sort of outdoor?
Yes, we actually did look into that. So we have a visualization that we can show you, which captures both spatial and temporal aspects. So here, the three colors that you see, these are different types of odors. And so I think you can look at the timestamp running. So it runs throughout the year. And then you can see how the odor reports keep popping up in these different areas. So this is something that we're still working on. So this would go well with the spatial temporal clustering. Unfortunately, we didn't have enough time to work on it any further. But yeah, I think hopefully this would be like the answer to your question.
And I'll just add as well, with the kind of odor source connection, we just don't have I think variable or accurate enough data for the temporal differences in emissions to really like make a connection. So, this is kind of what we were limited to, but because we disaggregated emissions estimates based on more seasonal trends in emissions, it's pretty averaged out. So we had looked into that earlier in the year and we decided we have to focus more on spatial.
I have a question about how do you think population density will affect the reporting of owners, and how does it maybe directly correlate with the number of emission sources? Because I think in high density areas will likely to receive more reports. However, it's less likely that there will be a garbage effect in the high density area. So I think if you're data, you can normalize kind of the number of reports with respect to the population there.
So yeah, it's kind of similar to the previous question, I think, but I think when we saw a strong signal around delta, we would just qualitatively view that as a very true kind of odorous area because it has a little bit less population density. When you do look at the reports, it's very clear that population is important for reporting, right? So the black are odor reports, and they do map on pretty well to population density. We had a couple kind of approaches where we tried to, let's say, simulate the likelihood of finding an odor report and then compare that to odor reports of different types based on population, population density being the driver for the simulation. But honestly, we just ran out of time and we had to kind of abandon it. But the workflow and the data exists, yeah, and that would be a really important next step for, especially if this work was going to be used in any sort of policy making. I think that population piece would be really necessary.
Yeah, that map was really good because I guess all the red circles are all low density area and I was low density. So that's really good.
Yeah, but the cannabis facilities seem to be a bit closer to population, high population density areas than the garbage facilities. These ones are the cannabis.
Thanks for really interesting work. A bunch of the questions I had were already asked, for instance, the clusters and looking at the odors and the space spatial development. But maybe my one remaining question is around uncertainty around the location of sources. So for some of the two industries that you selected, there are certainly point source emission sources for these, but there are also a lot of diffuse sources, right? Every time it's garbage day, all around the different places in the city, we're going to get potential garbage, diffuse garbage sources. For cannabis, there's cultivation, but there's also consumption, which might be also a diffuse one. I'm wondering whether in the other industry types, do you think there are anywhere it might be easier to tease out that signal because you're both confident about, let's say, the point source locations, but also that there's kind of a unique smell signature that would be really just, you wouldn't have all these other diffuse sources that aren't going to show up in your source map.
I think it would, so we only focused on these two industries because we only had data available for these. But I think if we were to look at any other industry type, I would say the chemical industries that are isolated from the mainland, I think it would be interesting to look at those. What are some other industries, the food and food
basically
processing?
all the ones we didn't have data for.
Exactly.
Because what you're saying is that cannabis is a highly mobile odor, because it's tied to behavior, right? And garbage also has cyclical patterns of behavior, whereas animal processing maybe doesn't, right? It's more tied to the facility. So if we could get some of that data, that would be excellent.
Yeah, I think it's also, so when we looked into the Delta cluster, we could see that the cluster, that area was a bit isolated compared to the mainland, and we could see how all of those reports were surrounding that one composting facility. So I think there's that behavior as well. So it's not, we can't really conclude that, for other industries it would be the case, but I think it's definitely worth looking into.
I think also one thing to consider though with the other industries, maybe with the exception of the food processing industry, is that they don't really have a signature smell in the same way that you'd associate a signature smell with garbage or cannabis. So it might be a little bit more difficult, even if we have those points for each facility, it might be more difficult to sort of connect a certain odor set to beneficiary.
Yeah, I think like also another thing would be if specifically like in downtown area, if you're surrounded by, you know, these different types of sources, and then determining even for the user to say, you know, what kind of odor is it, because it could be like a mix of two odors, you know. And so I think there could be something that we can add in the data collection, you know, the questionnaire as well, to improve that process so it's easier for us.
Well, I mean, and it's just like, this is such a like fundamental part of this analysis. That's kind of why we didn't go down the modeling pathway for now, because we felt like there was just so much, you know, the mixed smells, mixed sources. It's better to just give the data in a visual way and kind of let people do that kind of testing for themselves about the spatial relationships. Otherwise, you know, unless we had like full capture of like a lot more smells, you know, it's just going to be so uncertain.
Yeah, it ties back into the limitations that we discussed. Is we didn't do the modeling approach because we didn't have a representative enough sample, like a larger sample. But I think with a much larger database, we could be able to do that.
So you talk about community science at the beginning, and I know that you don't have the data about the person who submitted the report. So my question is that hypothetically, how would you interpret the result if the 550 reports were given by 550 people versus the 550 reports generated by 50? How do you think that will change you interpret the data? I mean, I know that you don't have that, but this is a question of that. I mean,
Yeah.
if you have that, how would you be using that to refine what you do?
I think previously we did talk about implementing a sort of scoring function to each of the reports that we had, and I think if we had constant users that were always updating the app and giving reports, then maybe you could perhaps assume that they were, you know, they have a trustworthy source, or sort of figure out some way of, I guess, assigning a score to each report.
Yeah, we talked about the trustworthiness of each report from, you know, the project, and also I think that's the exact question that we asked in the beginning of the project, is what if there's like multiple reports by the same person, and then it's not even that we could track the location, because the location, unless on the Smellvan app there's like a location of the user from where they're making the report instead of the location order. So I think that could be useful. And if we had access to the textual data, so I guess this is a reach, but we could probably use NLP to, you know, detect those patterns between different, you know, descriptions and see, again, anomaly detection using NLP. I think that would be pretty cool. But again, that's a reach.
But you also asked about how it changes the interpretation, right? And, you know, it's probably better to have 550 different individuals creating clusters that you can trust. That's, I think, intuitive. But I'm not so sure, it's less good to have less individuals reporting a lot, but it also doesn't invalidate the data. So I'm not really sure what you do in that case, because, you know, someone in Delta, maybe it just smells really bad right beside the garbage dump and they want to report all the time. That's still an odor, right? So, you know, I guess it's just the confidence. Yeah, I don't know if it really changes the direction of the interpretation.
I do think that the location from where the user is submitting the report could actually be useful. Like, there would be some cases where if someone's experiencing an odor in this area, they would make a report right there and then like stop it and like on the phone, open up the app and do it. Or they could go back home and, you know, do it from the home. And maybe if they do this multiple times, maybe we could see a pattern there, right? You know, we're getting a lot of reports just from this area, from maybe a similar, for similar odor types. I think that could be another thing that, you know, could help us.
Yeah. All right, if that's it. Oh, just one more?
I have a question as well, it's different, but I was wondering, Do you think there are any potential privacy concerns with publishing the locations of smell van reports because they could be used to identify smell van users?
Well, with the data that we have, it's actually, I guess, scrubbed of who each user is. So there's no real way of identifying that unless you have like the total data set, which
Yeah, we don't have that information in the data set that we were provided.
Okay.
It's always a good question to ask.
There are points on the map. Yeah. So depends, I guess, what the geospatial accuracy of that point is. You have to look into it, but that currently exists in the smell van in like
the reporting.
the prior version of the app. It includes that as well. So maybe yes is the answer. Like we know where the report came from, and that that's part of the data, so we can't quickly get around that.
Okay, one more.
There's informed consent, so when you use the app, you accept you consent to those potential hazards associated with it.
Yeah. I was just kind of wondering if like it would make, if, like you maybe consider, you could do some anonymizing thing, like where you randomly shift each report to a slightly different location, like
That
500
is
meters
in
away
the
or
app.
something. So that is
Yeah.
done?
But that's exactly the second half of my question, that, sometimes we worry so much about privacy that to the extent that the first half of my question of not knowing the user, you are actually losing the utility of the data set by just hiding some aspect of it. This is why, in the DNI, that people do a lot of things in terms of how do you balance between privacy and utility.
I would actually, get to know your thoughts on, the question that you asked, because now we're just, I guess, we're thinking about that, so.
It is a very complex question in terms of, whether it's 50 user versus 550, and even on the 50, it really definitely depends on the distribution.
Mhm.
And I think you guys have thought about that enough that I think it's as good as an answer that it is, but I think knowing, we're obviously trying to hide it, I think, but if there's some way of actually naming the people A, B, C, D, E, F, G, and anonymizing that, and then do some spatial ambiguity that you add to the data. I think it would actually be useful to actually have that user column, because I think there would be something that we could actually find out. Because, for example, the population question may or may not be relevant, because it might be population centered, but in terms of the number of unique users, it might just be similar. And so, so you need to know who actually submitted.
I believe in that case as well, there has to be some confidence from our side as well, because people could just use, a random name every time they make a report. So again, it's, another question that we would have to think about.
But I think this might be a question for you, Amanda. I think one of the benefits of this is that for those wonderful citizens who actually submit the smell report, it will be nice for them to know that somebody is actually doing paying attention. So if there's something that could link to that, somebody actually analyzed some of the data that we have submitted, I think that